Hi, good afternoon, everybody. Just confirm if you can hear and see. A lot of persons message me about having issues with the internet or joining, but we're gonna get started once you guys confirm that you can see and hear. So once you can hear or see, just type in the chat, good afternoon. I'm just confirming me so that I can at least know that everything working good with you guys. By chance, did you guys have any issues joining? And some persons telling me they're not getting in, but I don't know what could be the problem. So let me know if you guys had any issues joining. Let me see if I need to resend the link. It was easy. Okay. All right. So today's focus is algebra, which is question number 2. And it's probably one of the most important topics because it comes in different sections. So the stronger you are at algebra skills, the stronger you would be at all the other question topics. Okay. So if you guys are ready to start, what I would recommend that you try to do is see as much as you can, you write down the examples that you, especially those that you don't know. And if you can't write down the examples, you should take note of the questions that give you problems. So every time we do a question, I'm going to make sure I outline the topic. If it's something you know you're weak in, you need to make sure that you take note of that so you can work on it in your extra time. Sounds good? All right, so just let me know if you guys are ready by typing ready, and we're going to jump straight into it. All right, so I see Natalia, Gwen. So it's just Cloris and Austin. Let me know if you guys are good to go, okay? All right, so we're going to start off with June 2021, question number 2. So as you know, again, question number 2 is all about algebra. So we're going to start off with the first question. And before we get into it, let's read what it says. So it says 2 quantities n and t are related as follows. So they give you the equation. N is equal to the square root of t. Find the value of n when t is equal to 49. So this question is 1 max. So the first thing, whenever you do a question, look at how much max you're allocated. So you would know, okay, they expect you to do something simple. So don't overthink it. Keep it clear. Is that better? I think this question was a little bit hazy. But everybody seen it? So essentially, they want you to find the value of n. So you are required to solve this question. How do you do that? Always write back the formula. And they gave you the formula. Let me just check something quickly. All right. So this is, to be honest, a very easy question because they gave you the formula. N is equal to the square root of t. And so they ask you to find what is n when t is equal to 49. So all you need to do is substitute the value of t in this question. So you know the square root of 49. And even without a calculator, what's the answer? Because we should know all square numbers. What is the base number for the square root of 49? Which means which number When you multiply it by itself, gives you 49. Excellent. So the answer is 7. So you see, pretty simple question. You keep it straight to the point to get your full marks. So you will get a half mark here, and you will get a half mark for the substitution. So do not overestimate. Even though it's simple, ensure that you show the examiner that you understand what you're doing and how you're doing it. All right? Everybody good to go with this one? Pretty easy. Now, the next one is make T the subject of the formula. Anytime you see this expression, make something the subject of the formula, it means then that, let's say, for example, I have P is equal to A plus B. In this equation, P is currently the subject because everything is equal to P. So that's the point of making something the subject, having that thing on one side of the equation where everything else is on the other side of the equal sign. So how do we make T the subject of the formula? We again have to start off with the formula that was given. So let's write that. N is equal to the square root of T. And one of the things you want to do in these sessions is make sure that you're following. Make sure even before I do it, your brain should be thinking, can I do this question? Do I understand what this question is asking me? Because that's the only way this session will be extremely useful for you. All right, so let's go. We have here N is equal to the square root of T. What do we understand about making something the subject? It means then again, we need to make sure that T is on one side by itself. As it stands, do we have T? No, we do not. We have the square root of T. So how do I get to T? So let me just highlight T. That means we only want T. That means we need to get rid of everything else. In algebra, how do we get rid of something? We do the opposite to eliminate it. So my question to the group is, how do we eliminate a square root? What is the opposite of a square root? Just like we know, quick revision, addition is the opposite of subtraction. Multiplication is the opposite to division. So what is the opposite of square root? And the answer implied there, it's actually in there. Excellent, squaring. So it means then that I need to square this entire expression. And what is important here? What you do on one side, you have to do on the other side. So we see here what's gonna happen. The square and the square root is going to cancel out each other. And so we're going to end up with N square is equal to T. But we can't leave this like that because we want T to be the subject of the formula. And as it stands, who is the subject here? N square. So all you need to do is switch the two sides. So you have T in front is equal to N square. So let's just do a quick check-in. How you feel about these first two questions? Another thing you need to ask yourself, would you be able to work these questions on your own? So just give me some feedback while I move over to the other question. Everybody good? So I'm seeing people saying they think they can handle it. Pretty easy. Yep, pretty straightforward. Excellent. So what you need to keep in mind is the skills, the steps showing you working. Now, let's look at this question. I'm going to be honest with you, a lot of students struggle with this question in this year. Actually, this was probably one of the poorest done questions because again, you see a lot of words. When students see words, they run into problems. So one of the things I want you all to pay attention to is the translation of the information. What does that mean? How do you take words and sentences and express them using symbols and letters, turning it into the equation? So let's look at it. It says here, Ali is X years. So what we need to do is quickly underline this because this is something we need to hold on to. So I would just quickly write up here, Ali's age. And that's what you have to do. You see, when you see questions like that, pull out the information that is important. So Ali age is equal to X. Everybody following me so far? Because if you don't understand this, everything else will be more difficult. Yeah, come on, let's go. Give me some feedback because again, While I am doing it with you, it may seem easy, but then are you able to process the information on your own? That's the important part. So let's keep it moving. Jim is 5 years older than Ali. So this is another piece of information that is separate and in relation to Jim in comparison to Ali. So that means the first thing you need to be looking at, oh, you don't know Ali. Even though it's a letter, you know, Ali is X. And then you look at what Jim is now. Jim is 5 years older. So when it comes to an equation, that's supposed to be already processing in your mind. If somebody is older, 5 years older, that means how would I get my age, that person's age from my age? I would add 5 years, right? Then they have Chris is twice as old as Ali. And what you should realize is that they keep going back to whose age? Ali's age. So that means everything here is in relation to X. So everybody talk to me, everybody understand now? So it's either it's something happening to X because it's either they're 5 years older or twice as much. That's what you're supposed to be thinking. And the truth is, I feel like this year they're going to bring a lot of questions similar to this. So that's why I'm taking my time to make sure you guys are able to process it, because I feel like something similar going to come. All right, so let's look at what they ask us for. Write expressions in terms of X for Jim's age and Chris' age. So you see, this was a mistake a lot of persons did in the exam. Somebody went and said 5 years, but that's not true. Nowhere here did it say that Jim is 5 years old. What they did say though is Jim's age is 5 years. He's 5 years older. So our starting point would obviously has to be Ali's age, which is what? What is Ali's age, everybody? X. Very good. And so if Jim is 5 years older, we know, how do I get 5 years older? Just like what we discussed, we would have to add 5. Excellent. So I'm seeing people sending me their thinking and their answers, and I'm loving what I'm seeing so far. So don't be afraid to send me what you think in the private chat, okay? All right, so we got Jim's age. Now, the second part is for Chris' age. The same way we operated and got Jim's age is a similar approach, because as we see here, Chris is twice as old as Ali. So what should I write here? If something is twice, what does that mean? 2 times. Excellent. So this is some options you can have. You can have X times 2, which is the same thing as 2 times X. But could this be our final answer? In algebra, what do we know when you multiply a variable and a constant? You put them together. So your final answer is 2x. If you just write this, you're going to only get a half mark. So you have to make sure your answer is in its final form. Everybody following? Because you have to understand this before we continue. I'm just looking in the chat. I'm just making sure everybody is okay, feeling okay. All right, so let's look at the second part, which I must admit could be tricky. So I'm going to take my time and go through it so that you understand the process. All right, so let's take a look at the second part. So we got our 2 marks, we're good to go. In 2 years' time, so now you're supposed to be thinking, how will I represent 2 years in the future, or 2 additional years? So in 2 years' time, the product, so you're seeing some words coming out here, the product, 2 years' time, the product of Ali's age and Chris' age will be the same as the square of Jim's present age. So you realize we got a lot of things happening here. So let's break it down and take it slow. So what they're giving us here is 2 things that are equal. So let's read it again. They're saying that the product of Ali's age, let me just circle it. The product of Ali's age and Chris' age. So we see here the product of this is the same, or that means what? Is equal to the square of Jim's present age. So I hope y'all see how I'm grouping the relative information. So you understand how you're going to express this as an equation. That's supposed to already be showing itself here. So the next question is now, show that x squared minus 4x minus 21 is equal to 0. So let's be honest. Some people see this and they're completely thrown off. Anytime you see show that, don't panic. All they need you to do is work out what they ask you to work out here and prove that when you work it out, that this is your answer. So when you start, as you see here, let me just open up, they left a huge space for you to work with. So step 1 is to find your expression. Step 2, simplify it until you get the answer looking like this. Everybody following what I'm saying? Is what I'm saying making sense? Okay, so let's break it down. Let's take it step by step, because the challenging part now is going to be the solution part, or getting it looking like this. But let's break it down step by step. So let's go. They start with the product of Ali's age and Chris' age. So let's first identify what product means. Product means to do what? Exactly. So product means to multiply. So we're multiplying two things. Ali's age, and we should remember Ali is X. I hope y'all also realizing the difference between my X and my multiplication sign. This is something very important in algebra because people confuse them all the time. Okay. So we have Ali's age so far times whose age? Chris's age. And what is Chris's age? Chris's age is 2x times 2x. And that, so this is Chris, and that is equal to the square of Jim's present age. I intentionally did something and nobody realized. Anybody realize something? I was hoping somebody pick it up. Look at the first thing that I underlined in the expression. Should I be using their current age? What did they ask us to use? In 2 years' time. Yeah, I realize what I'm saying now? So they didn't ask. You realize the difference? They say in 2 years' time, the product of Ali and Ting age, that's one thing, will be the same as, you realize here now, the square root of Jim's present age. So it's 2 time frames they're using. Talk to me if y'all see what I'm saying. So the truth is, I should not be using X because X is Ali's present age. So what would be Ali's age in 2 years? If you, and think about it, anytime you're confused, think about it. If you are, let's say you are 20 years old right now, how old would you be in 2 years? Would you be 20 times 20 years? Or you would just add 2? Exactly. Everybody see that? So they're supposed to be X plus 2. Everybody following? Times, what would Chris' age be in 2 years? Exactly, plus 2. That's it. That's it. So that is equal to who? What is it equal to? Jim's present age. And because it's Jim's present age, what is Jim's present age? Let's see if we're looking. Remember, we found it before. So that means you need to use the answers from part 1 to determine what is Jim's age. Look at right here. What is Jim's age? And I am not going to write it because it's important for you guys to be able to see it. So if at least one person could tell me, we should be good to go. So what is James' present age? Based on the question before. X plus 5. Look at right here. We found it already. So X plus 5. So what do we need to do now? We need to simplify all of this. So what is this turned into? So we're multiplying these two expressions. Let's put them in brackets to make sure we understand what we're working with. So that means we're finding X plus 2, 2X plus 2 is equal to X plus 5. So before we continue, everybody with me on how we got to this first stage? Because if you don't get here, you can never go anywhere else. You can't find the answer correctly. That's the basics. And as we see here, it's all about understanding how to read the question and get the information from the question. All right, that's what we're focusing on, making sure we understand and read. So we see here, it was Ali's age in 2 years, Chris's age in 2 years. The product of those two things are equal to the square of Jim's present age. Nobody can pick up on something yet. The square of Jim's age. Is there anything I need to change? What do I need to change? Exactly. So I should have squared this. So I'm hoping y'all are seeing the purpose of me leaving these things out, because this is the mistake students make all the time. And honestly, when you're under exam pressure, it's understandable, but you have to make sure you reread. That's the purpose of me rereading, to make sure I represented the data correctly. So I see here in 2 years' time, so I know that's X plus 2. And I know that's 2X plus 2. And I know I have to multiply the two things. And then I back check is equal to, which means the same as the square of Jim's present age. Everybody see me? All right, so now we could take it from here. Now, one of the things I want to do in this class is show you the different ways to multiply this same expression. So we're going to do it 2 ways just to make sure y'all understand, because some people understand it in different ways. The first way is by just doing direct multiplication. So the first term, boom, 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 boom. So some people know it this way. Another way is by breaking it up to make it easier. So you multiply this by the entire bracket, and then you multiply the second term by the entire bracket. Okay, so I'm going to do both. So I'm going to do the longer way. And in most cases, people find it easier. So you can say X times 2X plus 2 plus 2 times 2X plus 2. Everybody see the first one? So let's break it down. So what we'll end up with is X times 2X is 2X squared plus X times 2 is 2X. So plus, we're doing the second bracket now. And just for you to make sure you understand how I got that, X times 2X is 2X squared. X times 2 is 2X. So same thing we're going to do here, plus 2 times 2X, 2 times 2. 2 times 2X is 4X, plus, what do we have here? 2 times 2 is plus 4. So we simplify. How do we simplify? We add what we can add. Remembering we can only add like terms. So that means I can only add these 2 terms here. So we bring back down 2X squared because there's no other X squared to add it with. But 2X plus 4X is 6X plus 4. How are we feeling? Are we okay? Do we feel overwhelmed? Are we following? That's the most important part. Following. Even if you're not 100% confident with the process, it's about making sure you understand. Okay. And if you realize expanding brackets, because that's what we're doing here, we're expanding brackets. If expanding brackets is a weakness of yours, you know, you just need to work on your practice. All right. Doing it now, the direct way is just by saying, again, multiply out, but that's what you're going to get essentially. So I'm just going to do it so you can see. Let me see if I could erase these arrows. All right, so let's go. We're multiplying first by x. So for those persons who use this method, so you would say x times 2x plus x times 2. So x times 2x is 2x squared plus x times 2 is 2x. Now we're going to multiply by the positive 2 plus 2 times 2x plus 2 times 2. That is plus 4x plus 4. So you realize it's almost the same thing, to be honest. So you end up with the same thing, 2x squared plus 6x plus 4. Everybody with me? So now I just want to get a gauge on how y'all feeling. Which one for you is the more easier approach? Is it the direct multiplication or is it the splitting method? So let me just get some feedback and let me just back check to make sure. Would you do the splitting or direct? All right, excellent. So regardless of which one you choose, you can always end up here. Again, you need to also expand this bracket as well, because what does this mean? This means x plus 5, x plus 5. Everybody with me? So however you expand it, and you're going to end up getting, so I'm just going to write that. When you expand it, you're going to get x squared plus 10x plus 25. So I'm going to do it on the side just for those who may not be confident in how I got that, because this is called a perfect square, if you all remember, right? So there we go. X times x, x times 5. 5 times x, 5 times 5. So x times x is x squared plus x times 5 is 5x plus 5 times x, 5x plus 5 times 5 is 25. Okay, I think, to be very honest with you, this should be something that you should practice a lot of to be strong in it. All right, so now that we have that, so let me ask you a question. So let's take it from here. Let me just remove this so it don't look as confusing. Hold on. So I'm just gonna crop this out. Oh, let me just write it over. Let's give myself some space. So far, this is how far we've reached. 2 x squared plus 6x plus 4 is equal to x squared plus 10x plus 25. So everybody with me, talk to me. At least were you able to follow to understand how we got here? No, you don't do nothing else. Whenever you reach a spot where you feel confident, you do not continue until you back check what the question asking you for. So what do you realize here? Let's zoom in. They say show that the equation is this, right? What do you realize the difference is? We have 0 on one side and we have one linear equation. So guess what that means? What would you do then? If we want 0 on that side, that means we need to move everybody on the right side over to the left-hand side so we have nothing on the right. Everybody see now? That's all you need to do. And when you do that, you just got to hope that you work it out so that you get the same answer. All right, so let's do that. When we transpose, and you should know that's what this process is called. Whenever you move anything over the equal sign, it's called transposing. And you should also remember, whenever something is moved over, what happens to the signs? The signs change. So the x squared, so I'm just going to write back everything from the original equate side, 2x plus 6x plus 4. So you realize we changed nothing on the left-hand side. So it's all about just bringing everybody over. So when x squared come over, what is it going to become? Minus x squared. Agreed? When plus 10x comes over, it's going to become what? Minus 10x. When plus 25 comes over, it's going to become minus 25. And that's how we get 0 on this side. So from now on, anytime you see an equation and they say show that's equal to 0, it means you eliminate everything from this side of the equation. Everybody with me? So now we need to simplify. This is basic algebra now. What do we do with all of this? We know we adding and subtracting. So what are the rules for addition and subtraction? You could only add and subtract like terms. So we need to then group our like terms. So let's break it down. We have a 2x squared and then we have a minus x squared. So we're going to go 2x squared minus x squared. And we should know that x squared by itself just means 1x squared. Just that the coefficient 1 is understood. Okay, so quick reminders. Next, who do we have next? We have our x's. So we done deal with our x squares. And if you need to do this, guys, do it. Whenever you're done, rearrange it and you use it, scratch it out. So you know you don't remove it already. So let's look at what's left. We have a plus 6x. So let me use green. I have a plus 6x. Do I have any other x's here? Yep, I have a minus 10x. Keeping in mind, the sign in front always moves with the variable, okay? So that's why we have a plus 6x and now a minus 10x. Everybody feeling okay? Anybody, hopefully everybody don't feel completely lost. Check in with me. Let me know if you're okay, if you're following. So now we have our last two terms, plus 4 minus 25. So we have our two constants in the end. Okay, no problem. Equals 0. So we could take it from here because it's simple algebra. If you have 2x squared and you minus 1, how much going to be left back? Just x squared. CX, you don't expect it to ever put that 1 there because the 1 is understood. Right? Now we need to consider this whole equation separate, which is integers, because a positive minus a bigger negative can give me a negative number. So what should I put here? Let's see if we remember our integer rules. So plus 6x or positive 6x minus 10x, what will I have left back? Excellent, negative 4x. When the signs are different, subtract the two values and your answer take the sign of the bigger number. So 10 minus 6 is 4. And who is bigger? Negative x. So negative 10. So that's where your answer would be negative 4. Let's do the next one. Same thing here. Plus 4 minus 25. What should I write here? Negative 21 equals 0. So now that you're here, what do you do now? You back check to see if that's the same thing they asked you to show that you will get. So let's see if that's what we got. Let's go back up. Yup. So guess what? You put this little box here. This little box here means that you don't do what you're supposed to do. It was proven. Question has been proven. Everybody with me? Now, considering looking at this question, be honest, would you have known that that's all the things you needed to do? Would you have been able to, if you don't put it box, you don't lose any marks. But it's all about making sure that you show them that you know that you're done, that that's it for you. So great question. So I see some people being honest, they knew that they wouldn't have been able to figure it out. So you realize here, what's the most important things? Write out the information they give you. When you write out the information they give you, in algebra, it's all about solving. What does solving mean? If you see a bracket, you work out the brackets. You break it down until its lowest terms. And because they gave you a specific equation, so your job is to figure out the puzzle to make it look like the answer they gave you. So everybody said they wouldn't be able to have done it on their own, and that's perfectly fine. It's about being exposed, and it's about being able to understand the steps and understand how you should be thinking. So my second question is, do you understand the way you should be thinking when you see questions like this? We're gonna come across a few more. So we're gonna start to practice how do we take these statements and sentences, break them down and solve them. So now this question is about understanding. Do you understand how you should be thinking? So I see 1 yes, 2. I seen somebody saying they're happy that they see this because they would have never understood what to do. Okay. Okay, somebody said not yet. That's perfectly fine. That's perfectly fine. We're gonna get there. But Gwen, did you understand the steps though? Did you understand each step by step? Okay, that's a start. That's a start. All right, so let's look at the next question. So our answer was, we ended up getting, even though I erased it, we ended up getting our answer, which was x squared minus 4x minus 21 is equal to 0. Now, the next question says to do something. Calculate Ali's present age. Based on the symbols, what symbols represented Ali's present age? So if you need me to zoom out for you to look again. So guess what is question? Thank you. So Niall said finding X. Do we agree? If they ask us to find Ali's present age, do we agree? Because remember at the very beginning, we wrote it out that Ali's age is equal to X. So if they ask us to calculate her age, that means they're asking us to do what? Solve for X. Talk to me. Remember, we can't continue unless I make sure you guys at least understand what they're asking you for. So everybody agree that this is what they're asking us for, to solve for X. And what you should remember, whenever they ask you to solve, it means that you must state at the end, X must be equal to something. That's what they're asking you to find, the value of X. So calculate X, solve for X, same thing. Now, I'm just going to take a quick moment to highlight the different ways that you can solve an equation like this. So in an example like this, you think you got to start from scratch? This type of question, you have to use the answer that you found before to find the answer that you need to find now. What do I mean? What did we find before? We found this equation. This equation is x squared minus 4x minus 21 is equal to 0. What we should remember is that we can solve this equation, and solving this equation will give us the different values of X or the value of X. Everybody with me? What are the different ways of solving this equation? You could solve by first factorizing. You can solve by using the quadratic equation. And we should remember the quadratic equation. In the booklet, they give you this equation at the front. It looks like the square root b plus or minus the square root of all them things. B squared minus 4ac divided by 2a. Right? And the last one is completing the square. Now, the truth is, completing the square is the hard, now I won't say hard, it's the most challenging approach. So that should be the last thing you look at. So let's look at the first option. So anytime, let's look at this question here. Anytime you have to solve, go through the list in your mind. Start off with factorize. Can I factorize that? That's something you need to ask yourself. Is this a question I could factorize? And I'm just going to take a moment to just go on the side and revise what are our factorization processes. Because if we don't know that, yeah. So the first type of factorization is using the distributive law. What does that mean? That means that I could pull out things that the equation have in common. So for example, let's say you have 2a plus 2b. This is a distributive factorization because my question is, what does these two terms have in common? So we're doing a quick factorization revision. Let's go. What do they have in common? 2. So that means what can I do when I factorize? I pull out or I divide by the common entity. So if I divide both sides by 2, I pull out 2. What would be left back? A plus B. Everybody with me? So this is using the distributive law. It means pull out what is common. So quick revision. Yeah. Second type of factorizing, by grouping. How do we factorize by grouping? You must have 4 terms. You must have 4 terms where the first 2 terms have something in common. So an example like that would be, let's say, let's use the same 2a plus 2b plus 3a plus 3b. I'm just going to use this simple one. So what is the difference between the first one and the second one? Why can't I use distributive here? All the terms don't have one thing in common. So even though the first 2 have 2 and the second 2 have 3, and even though there's an A and there's an A, all of the terms don't have at least one thing in common. That's the only way you could use distributive. All of the terms must have one thing in common. Everybody following me? So that is the purpose of grouping. So I would group these 2 because they have something in common. I would group these 2 because they have something in common. And then you factorize them separately. So if I factorize this, I would get 2a plus b. If I factorize the next bracket, what would I get? 3 open bracket a plus b. And are we done? So that's my question for everybody. Looking at this, have I completely factorized my equation? Remember, this is quick revision. So let's go. I see one person respond. You need to start thinking, is this completely factorized? Remember, factorizing means that you're usually pulling out something like that's common or you're grouping stuff. So I'm just waiting for a few more responses. No, we have not factorized completely because look at the brackets. This bracket and this bracket is the same. So I could factor out the brackets. So if I take out the brackets from both sides, A plus B, what's going to be left back? 2 going to be left back. So I'm putting a separate bracket, 2. If I take out A plus B from here, what is going to be left back? 2 plus 3. Everybody see that? So this was a perfect example of factorizing by grouping. You know, you could add 2 plus 3 here, right? The order kind of matters because sometimes it could affect your solution. So always put the thing that you factor out in front and what's left back behind. Everybody with me? So that's factorizing by grouping. I'm just going to quickly just touch on the others. The reason is because I don't want to spend too much time on this, but I want us to go back to the questions. The next one is the difference of 2 squares. This one is self-explanatory. We should remember if I have a square minus b square, realizing that the first term completely is a square number minus a square term that's completely a square term. How do I factorize that? I factorize it by using this formula. A plus b, a minus b. So what do? We find out what is a, we find out what is b, which is the base of a square and the base of b square, and we just substitute it, and that's your answer. This is the easiest one to factorize. Next one is perfect square And I hope you could write these things down if you can write fast enough. These are very important summary notes to have in your books, because these are the things that you should be thinking when you start to see anything about factorizing. You're supposed to be thinking distributive. If it's not distributive, next by grouping. No, next, difference of two square. No, perfect square. So let's just look at the perfect square. Revision, all of this is revision. So if an equation look like this, a square plus 2ab plus b square, or if it looks like this similarly, a square minus 2ab plus b square, this is how we factorize those equations. It's going to be a plus b square or a minus b square. I'm going to do a separate session just on factorization because it's a very, very broad topic. So that's another one. And the last one that's most important is the AC rule. How do we use the AC rule? So you would have an equation ax squared plus bx plus c. How do you factorize it? You multiply a and c, you find the factors, and then you put them in a group and you rewrite. I know a lot of you probably like, what is V saying? But if you're revising, these things would be things that are fresh in your mind. So you find AC, which is A times C, find the factors of those things, and then you rewrite the equation. And then you factorize by grouping, and then you're done. So that's the general steps for using the AC rule. We're going to look at some examples coming up in the next exam that you're going to see what these steps mean or be reminded, okay? But be honest with me, how much of y'all remember? Out of these, one, let me label it. So you can give me a number. 1, 2, 3, 4, 5. Out of these 5 different ways of factorizing, how much you remember? So you got a distributive, grouping, difference of two squares, perfect squares, AC rule. Be honest, how much do you remember out of the 5? Okay, not so bad. If you don't remember any, that's perfectly fine. This is where you learn to remember. Somebody said 3, so you remember 1, 2, and 5. Okay, 3 of them. Okay, not bad. If you don't remember any, that's okay, don't panic. All right, so as I was saying, this is one approach to solving by factorizing. So let's take a look at how we're going to use it. That's the approach we're going to use here. Which one you think we could use? Can I use distributive? You need to tell me yes or no. Can I use distributive here? Because that's the thing. If you can't tell, that's the hardest part about solving anything. So we're solving using factorization for sure. But which one? So everybody, whether you're sure or not, I need to hear yes or no. Can I use using the distributive law? Because that's how you should be thinking. Okay, so Shaquanza think yes. What about everybody else? Let's go. Okay, so most people think yes, but guess what? No. Why can't I use? So let's look at why you can't use it. So you stick in your brain how to determine if it's distributive. What's the rule for distributive again? All of the terms must have one thing in common. So let's look at this equation. All of the terms don't have x, so that can't be it. Let's look at the coefficients. None of the terms have one common constant that they have in common. Everybody see that? So we cannot use the distributive because the distributive needs something that all 3 terms have in common. Everybody with me? Everybody understanding now? What's the next one? Grouping. Can I use grouping? So let's go again. Yes or no? Can I use grouping? No, because what's the first thing that you just kind of look for? You have to have at least 4 terms. You must start off with 4. You can't group if you don't have 4. So excellent job. At least we remember that one. That's a good sign. So very good. So let's look at the next one. Is this the difference of 2 squares? And the reason I'm spending time on this is because that is why factorization just gives students struggles, because they don't know how to determine which process to use. No, you can't use the difference of 2 squares because first of all, we don't even have 2 things and we don't have 2 squares. So it can't be the difference of 2 squares. Is this the perfect square now? So the next one is perfect square. What y'all think? Is this the perfect square? The first thing you could look at to determine if it's the perfect square is if the first and the last term are square numbers. 21 is not a square number. So that's the first thing. We ain't got to go no further. We know we cannot use the perfect square. So what's the last thing that we got in we bank? The AC rule. With practice, you should be able to go through this list in your mind faster and figure it out. So let's look at AC. In this example, what is A? A is 1 and C is negative 21. Everybody see that? So we're using the AC rule. And the AC rules means we have to find AC first. So A is 1, C is negative 21. 1 times negative 21, let me write it here. 1 times negative 21 is what? Equal to negative 21. So what do we need to do? We need to find the factors of negative 21 that can give us what? Negative 4x. Everybody remember that? Because we did this. So let's start off. Because it's a negative number, one is going to be positive, one is going to be negative. So just for the purpose of learning, I'm going to go through all the factors. But the truth is, you should know it could never be 1 and 21. Because the only 2 options you could get here is either you could get, what was the option? Remember, we had to find the sum of the 2 of them. So if I do that, this is negative 20, or I can get positive 20. So I know it can't be this. So let's look at the other options. What other 2 factors we could use? We can't use 2 because 2 is not a factor. What about 3 times 7? So we're going to start off with negative 3 and positive 7 and positive 3 and negative 7. So if we add them, we need to see which one will give us the negative 4. If I add these 2, this is going to give me positive 4. Everybody agree? Because negative 3 plus 7 is positive 4. But if I add these 2, 3 plus negative 7, I'm going to get negative 4. So guess what? We have found our 2 factors that we need. Before I continue, everybody with me? All right, so based on the rules, so I just want to recap to show you the steps that I outlined here with the AC rule. So you realize so far what have we done? We multiplied AC and we found our factors. So now our next step is to rewrite the equation and then use grouping. So what do you mean by rewrite? Do we remember what we mean by rewrite? So instead, we're going to break down 4x into these 2 numbers. So it's going to become x squared, because we bring it back down. The only thing changing is the middle term. So instead of writing negative 4x, what should I write? I should write plus 3x using the first factor, and then minus 7x using the second factor, and then I put back minus 21 equals 0. Because remember, the rewriting is to move from 3 terms into 4 terms so that we can use what? We could use our grouping. That's the whole point, you know. The whole point is to make it easier to factorize by changing it from 3 terms into 4. So let's go. If we group in, we know we're going to group the first 2 and we're going to group the second 2. So let's just zoom in here. How are we feeling so far? Everybody good? Just gonna take a quick minute just to let certain things settle in and get some feedback, because remember, you're hanging in there. Remember, we haven't done algebra in a long time. So a lot of this is maybe like, just coming back. So again, remember, this is your opportunity to write down. If you know factorizing is a weakness, you should write down factorizing is a weakness, okay? So let's continue. This is easy because we know how to factorize using grouping. You focus on the first bracket. What is common between x squared and 3x? Everybody help me with this one here. What's common between x squared and 3x? What can I pull from both terms? Excellent. So I could pull out 1x. Very good, everybody. Very good. What is going to be left back? Let's see if we could get that one too. If we pull out x, what's going to be left back? Don't forget, it can't just be 3, because remember, we have an x squared. And remember, x squared means how much x is? X times x. So if you pull out 1 can always be left back. Everybody see that? So when you pull out 1x from x squared, just gonna write it in green, x gonna be left back plus 3. How do I back check to make sure that I pull out the right thing? If you multiply them, x times x, x squared, x times 3, 3x. So that's a quick way to back check if you did it correctly. Everybody with me? Very good. So let's go. Second bracket. What is common here? Keep it in mind, the 3 things you should be checking off. You have the signs, if the signs are the same, the coefficient, and the variable. So we have here minus 7x minus 21. And this is where students just make a lot of mistake, because what they just forget is that, look at it, both terms have a negative. So guess what I could pull out? I could pull out the negative. Everybody see that? And remember, this and this are 2 different terms, because 21 is a number, which is a constant, whereas negative 7x is a variable. No problem. That's the point of making mistake. So everybody learn. So we pull out our negative. What else can I pull from both sides? Can't I pull 7 from both sides? Because 7 is a factor of 21. Agreed? So I could pull out 7. I cannot pull out x because both of them don't have x. So let's see what's left back when we pull out this negative 7. When I pull out negative 7 from this, what is left back? Just the x. When I pull out the negative, what's going to be left back? A positive. That's the next part. Everybody does get confused. Everybody see what just happened there? If you pull out this negative, it's not that no sign gonna be left back, You're just making it positive when you pull out the negative. Everybody with me? Because this is something I want you to be very careful of whenever you're pulling out or factorizing. So let's go. When we pull out 7, so 21 divided by 7 is 3. How do you know that you're going right? What is something that at this point tells you, oh, I could feel good? Woof. I feel good, I feel good, I feel good. What is a sign that you're going good? Anybody realize the sign? When the 2 brackets are matching. Now, just be careful. It don't happen 100% of the time, but it happens. I would say 89% of the times. It's only if CXC feeling super savage, they will give you an expression where they don't match. And we're going to look at some examples of cases when that do happen. So now that we realize we got matching brackets, what do I do now? We know that we need to pull out our matching brackets. So we're going to pull out x plus 3. When I pull out x plus 3, what's going to be my next bracket? Somebody tell me what's going to be my second bracket. Excellent job. Excellent job. Are we done? Now, this is the part, even for both classes, I have to either not introduce you to, but we didn't touch on this as much as I would have liked. So we need to focus on this part. Remember, they didn't ask us to factorize, right or wrong. This is just the process we're using to find the value. So everybody understand what I'm saying for now? How do we know we're not done? We're not done because they didn't ask us to factorize Ali's age. They said to find Ali's age. So the truth is, we solve using factorization. So this is the step now that all of us need to focus on. Whenever you have this just simply means that if you have two things and you multiply, so let's say the first bracket is A and the second bracket is B, and we're multiplying them, right? Everybody following me so far? So I am just using A to represent the first bracket and B to represent the second bracket. When you multiply two things by 0, what does that mean? How is the only way you could get 0 when you multiply two things? And when one of those things is 0. Everybody following me? Because if you say A times B is 0, that means either A is 0 or B is 0. That's a basic concept that you have to know and understand, especially with solving. Anytime they tell you something is 0, it means that either the first thing is 0 or the second thing is 0. So guess what we need to do now? We need to separate it, and that means we need to say, therefore, x plus 3 is either equal to 0 or x minus 7 is equal to 0. So let's do a check-in here. Everybody understand how I got here and why we do this, why we separate them, and now we have two equations. And we should be able to take it from here, right or wrong? We should be able to take it from here because we can now solve for x by transposing. So if I want x, I just need to do what? Move this over and move this over. So guess what we're going to end up having? And you're going to see what's going to happen. X in this case is equal to minus 3, or x is equal to positive 7. Let's be real. Ali can't be 2 ages, but let's be even more real. Can anybody be negative 3 years old? So guess what you have to do here? You don't know the answer. Which one is the answer? Which one can give us the answer? Which one is the correct one? The one that says x is equal to 7. Very good. But you can't just leave it like that. You have to say, since x is equal to minus 7 years, not minus 7, minus 3, sorry. Since x is equal to negative 3 years is not valid, Ali is therefore 7 years old. 7 years old. Now, the truth is, there should have been 3 marks. This is a lot of work for 2 marks. CXC moving stingy with the marks. But let's just zoom out now and break down the different processes that got us here. Because there are a lot of questions that are just like this. So you see, if you could understand this one, all the other questions just come just like this. So let's go again. What was our step 1? Step 1 is that we needed to solve for x, and we chose the solving by factorization. Okay, so that means our first step was to just do what? Factorize. So all of this was just the factorization part. And this was so that we could get our 2 equations to solve for x. Everybody with me? So understand the 2 different steps. Factorization gives us an equation that could easily find x, and that's what we used it to find. Okay? Now, the direct way is to use the equation. Let me see if this working here. I have the equation. So let's look down. Actually, they just did the same thing. They did the same thing here. They use factorization. So it means that CXC expect you to use factorization. You see how short they did this, but let's be real. How much persons could just go in straight and factorize just like this? So here we just put AC rule. This is for advanced students. And the truth is, you realize it got to the same steps. X is equal to 7 or X is equal to plus 3. And then they solve for the 2 value. And you see here, they say invalid. So therefore, you realize, again, they're using sentences to make sure they communicate the answer. So these are the parts that you need to master. And that's the difference between a grade 3, a grade 2, and a grade 1. So let's go out of 10. How do you feel about the concept? Your understanding of the concept of this question? This last part specifically. Understanding that you needed to solve and the process of solving, but the first one you should be looking at is by factorization. So out of 10. That question was rough. Okay, I've seen 5s, I've seen 6, I've seen 8. And luckily for us, because we're doing this now, this gives us an opportunity, and I'm going to continue to say this. If you realize, oh my God, I'm struggling in this, this is where you know you need to go and utilize your notebook, utilize previous videos, questions to practice and bump up your skills in algebra, especially factorizing and solving. So I'm still looking to see more feedback on questions and how you felt about that question. So overall, if you were in CXC, that's what you should be asking yourself. Would I be able to answer that? Yikes. Yes or no? If it's no, no need to panic. No need to fluster yourself. It's all about identifying your weaknesses. So if it's a no now, that don't mean it ain't gonna be a no next week or the week after. All right. So let's go into our next year. What year is this? January 2021. Okay, let's go. Oh, look at that again. First question, factorize. So guess what we're going to do? Tell me what type of factorization is this? We just went through all of them. What type of factorization is this? If you're willing to try. And I think you should try. That's the first step. Even if you're not sure how to do it, which type of factorization do you think it is? No problem. At least you came, and so you just try to pick up on where we are now, okay? Excellent job, everybody. Okay, so we got the dish AC rules. So anybody else? Let's go. The truth is, when you look at this, it's only 2 things that could come to mind. Because it's a subtract by 2 things, the truth is it could be the difference, but you know why it can't be the difference, because M and M is not a square term, so it can't be that. You know it can be grouping because it's not 4. But if you start off with the first one, which should always be distributive, you would know it is distributive because both of them have what? Something in common. Agreed? What is the thing that they have in common? That's the next question. You should be looking at the signs, you should be looking at the coefficients, and you should be looking at the terms. When I look at the coefficients, first of all, both of them are positive, so I know it's positive. When I look at the coefficients, 12 and 4, what do they have in common? 4 they have in common. Agreed? Then when you look at the variables, what can I pull from both of them? I could pull the n from both of them. So let's look at what's left back. So if you know 12 divided by 4 is 3, and you had 2 n's because n squared is n times n, and you pull out 1. So how many n's left back? There's an n that is left back. You put the subtraction sign. You went with the entire 4. So you know you ain't have a coefficient, or if you want, you could put 1. Then you know you went with the n. So what's left back? Just the m. And that's your answer. Let me use a green bracket. Let's go, talk to me. How are we feeling about this one? Again, this was factorization by distribution. Everybody okay? All right, so guess what? Now we have show that this is this. First thing first, what is this topic? This topic is algebraic fractions. So the first thing that you should be thinking about is the rules of fractions. What's the rules of fractions? If you're subtracting and adding, you find the common denominator. If you are multiplying, you're canceling. If you're dividing, switch and flip. Okay? So what is our current state here? We realize that this question is a show question. What does a show question mean again, guys? They're going to give you something to do and they don't give you the answer. So all you need to do is work this out and make sure that your answer look like this. Everybody with me? Because sometimes they could just say solve or simplify. But whenever you see show, this is a proof question. That means you need to work out the left-hand side to show that it is equal to the right-hand side. Everybody with me? You realize how often we see questions that say show? That's very important to understand. So don't stress out yourself and think that you gotta carry this over. No, 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 no. No, 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 no. This just means work out the left-hand side and prove that it is the same thing as the right-hand side. So let's first of all start off by writing the question. So let's go. So we have x over 1 minus x minus 4x. You know why this is an easy question? Guess why this is an easy question? What is the denominator for 4x? What is the denominator for the 4x? How do we express? So for example, I'm just going to come to the side. If I give you 3, what is the denominator of 3? What is the denominator of any whole number? So this is something you need to remember. Not because we doing algebraic fractions mean the rules them change. It's the same exact concept. So if you have a variable, right? If you have a variable and you want to change it to a fraction, you just put it over 1. So if 3 as a whole is the same thing as 3 over 1, 4x as a whole is the same thing as 4x over 1. Everybody with me? It's just like if I had 1 1/3 plus, let's say, 2.
Here are some results.
Okay, so that's something you need to remember. Basic rules. All right, so let's take it from here. What is the rules for adding or subtracting two regular fractions? What do we always look for? Don't even study this right now. What is the general rule? Finding what? What must we find? It starts with a L. Excellent. Find the LCM. Now, why did I say this is an easy question? The LCM of 1 and anything ain't the thing. So the LCM of 3 and 1, let's say these are our two denominators. So let's say we had 2 over 3 and 2 over 1. The LCM of 3 and 1 ain't just 3. Talk to me, because these are the basic things that we need before we even touch a question like this. If you ain't understand this, if I was to add this, if you ain't understand why the denominator is 3 here, you're not gonna understand what the denominator is for these two items. So I see Shikwanza saying yes. Anybody else? Remember, all I need y'all to do is confirm or deny. It's about making sure y'all understand the principles. You know, me really care about the questions themselves. I'm looking and paying attention to the principles. All right. So anytime you're adding and subtracting two fractions, whether they're algebraic fractions or not, you always have to find the LCM. So the trick is, whenever it's two algebra terms, you got to figure out, okay, what is the LCM? And in any case, if you can't figure it out, you know what you just do? You multiply the two of them. Because let's look at this one. If I gave you 1/3 plus 1/4, if you can't find the LCM of 3 and 4, what can you do? You could just say what? 3 times 4 in it, which is what? 12. That's the same concept you use for algebraic fractions. So we have 1 minus x and 1. So guess what the LCM is going to be, guys? If I multiply this by 1, it can just become 1 minus x. Confirm or deny. Let's go. Yes, no, yes, no. How do you know you're going right as well? Keep looking here. Keep checking here. Always, every time you do something, look here to see if it's matching up. That's the point. That's the point. Make sure that you're working towards getting your answer to look like this. All right, so guess what I am going to do? I'm going to simultaneously work out a regular question using the steps and then work it out with the algebraic side so that we could remember the rules, okay? Let me move this up a little bit so we could just have them on the same level. So 1/3 minus 1/4. So my LCM would be 12. Agreed? All right. So first thing we say is, how many times can I get 3 from 12? How do I change 3 to 12? I multiply by 4, right? Whatever you do to the bottom, you do to the top. So the first numerator I will get is 1 times 4 is 4. And then I put a subtraction side. Everybody with me so far? So you do the same thing. You say, how many times can 1 go into this? Or what do I do to change this? In this example, I get lucky. I just multiply by 1. So what am I going to start off with? Just x. Everybody see how I just get x here? No, let's do the next side. What do I do to 4 to get 12? I multiply by 3. Because 4 times 3 is 12. Whatever you do to the bottom, you do to the top. So 1 times 3 is 3. So let's do the same thing here. What do I do to 1 to change it to 1 minus x? I multiply by 1 minus x. Whatever I do to the bottom, I do to the top. Everybody see that? But because we already have the brackets, do I need to put the multiplying here? So you put the subtraction sign, correct? But then you just write what? 4x times this. So 4x, open bracket, 1 minus x. So let me know if you're following so far. Let me just put this in a different color. Subtract. So this is the two sides match up. When it's just numbers, when it's just algebraic terms. How we feeling? I want to do one more. Even after this, we're going to do one more to kind of solidify the steps. Because this one is a bigger challenge question. If you could do this, you could probably handle any algebraic fraction question. All right. So we are here. If you look at this, based on your knowledge, what do you always try to get rid of next? You're going to always have a denominator because we know that don't match up. So we ain't got to trouble the denominator. So our focus should be where? The numerator. We're trying to get the numerator to look like this. So what do we do to get that done? What should we do next? Anybody? What should our focus be on now? We must get rid of something. When you say cancel out what? Let's look at this here. Look at the top alone. That's perfectly fine. Anytime you have brackets, guys, anytime you have an equation with brackets, you must get rid of the brackets first. Everybody with me now? In terms of what I'm talking about? You don't trouble the denominator stays the same. How do you know? You look up, you realize, oh man, the denominator is the same. So the only thing that you need to focus on is your numerator. And if you want to simplify it, you have to get rid of your brackets. So everybody following me now? All right, so let's go. We pull back X, we pull back minus. So let's go. Let's multiply all the brackets. When I multiply all the brackets, what do I get? I get... Wait, I just need to check something. Yes, let's go. So what am I going to get? I'm going to get minus 4x. What else will I get? Excellent. Well, what will I get next? Anybody else? Remember here too, when you're multiplying, you're not just multiplying by positive 4x. You got to take into consideration this. So it's going to be minus 4x times positive 1, which gives us minus 4x. But minus 4x times negative x going to give us positive 4x squared. All right. So next step, what do I do next? We have addition and subtraction. Is this my final answer, or I could add and subtract something from something? So is it this it? So that's the question I'm asking. Is this the final answer, or we have to go more? Go more, right? Because I could subtract what? I could subtract this 4x from this x. So what is that going to give us? If I subtract 4x from x, that's going to give me minus 3x plus 4x squared over 1 minus x. But guess what we're going to do? We don't like how this looks. So CX, I expect you to switch these two. When you switch these two, you're going to end up with 4x squared minus 3x over 1 minus x. So now that you reach here, let's look at our answer that they gave us. Let's see what we need to fix. Anybody seeing it coming together? So this is what you're looking at. Look at the right hand side. We're looking like we close now. If you can't see it, I can't go no further. So I need y'all to tell me, are you seeing the connection? So who could tell me what would be the last step now? How do I go from here to this? What do I have to do? What did they do? A F word. What did they do? What's the F word that they did? Excellent. They factor out x. You realize that's the only difference, that they pull out the x. So the next step, the last step, is just them taking out x. So they pull out x. What is left back when you pull out x from 4x squared? Just 4x. Minus when you pull out x from 3x, what is left back? Just 3. And you pull back the denominator. So let me just erase this since we're done with that. But that's it. Everybody see that? Again, algebra is probably one of the most challenging topic areas. The earlier you start realizing what you don't understand or what you're not strong in, the better for you. So you could start getting more practice. Y'all want me to do one more algebraic fraction question, an easier one, so we could just make sure we understand the steps? Want me to do one more on the side? All right. So one person said yes, that's enough for me. So let's do an easy one. Let's look at x over 4. Let's do an easy one, because one like this came recently. X over 4 plus y over 3. This is an easy one. You know how you know it's easy? Because your two denominators are whole numbers. So let's go. Because we're adding, we must find what? The LCM. What is the LCM of 4 and 3? Excellent. Same thing like what we did before. How do I change 4 into 12? I multiply by 3. Whatever you do to the bottom, you do to the top. So x times 3 is what? Three x. Never x3, okay? Never x3. X times 3 is 3x. So we put the plus sign. Let's go. 3 into 12. How many times? What do we do to 3 to change it to 12? We multiply by 4. Whatever you do to the bottom, you do to the top. So what you're going to end up with it at the top? 4y. Now my question to you is this our final answer? Guess what? It is. And guess why it is? Can I add y's to x's? So yeah, realize there's nothing else here you could do. There's nothing. You can't even factorize because they don't have nothing in common and you can't add two of them. So this is your final answer. Keep in mind the rules. You could only add and subtract like terms. So this was a very easy example. Everybody understand this one? The steps of this one? I'm going to do one more where there are variables in the denominator. So I'm going to switch it. So I'm going to say 4 over x now plus 3 over y. This now, same rules, but guess what? Instead of numbers, we're looking at variables. What is the LCM of x and y? Excellent. Keeping in mind, if we can't find a number, we just multiply the two of them, right or wrong? So x times y is just xy. Before I continue, everybody with this part? Okay, what was the step here? How do I change x to xy? What do I multiply to x to get xy? I multiply by, somebody tell me, what do I multiply to x to get xy? Excellent. Whatever you do to the bottom, you do to the top. You realize it's the same procedure. I want y'all to look at the two of them. So what would I put here? 4 times y is 4y. Y'all okay so far? Put back the plus sign. Same thing again. How do I change y to xy? I multiply by x. Whatever you do to the bottom, you do to the top. So what you're going to end up with? Can I add these two? Or this is my answer? That's the answer. Okay, so as you see here, the principle is simple. Find the LCM. Ask yourself, what do you do to the old denominator to change it to the new denominator? Whatever you do to the bottom, you do to the top. It does not matter if it is a letter or a number. It's the same exact rules. Sometimes it's an entire bracket. It's the same exact rules. Everybody with me? So you see here, that's the approach we have here. And the only difference with the one that we did before is that it involved a bracket rather than just a single number or a single letter. Everybody with me? And you just follow your rules and you simplify. So as you see here, once you get to here, it's just algebra rules you're following. And what are algebra rules? You multiply out a bracket anytime you have a bracket. You add what you can add, you subtract what you can subtract, you multiply what you can multiply. And you keep going until you can't do nothing else. Everybody with me in terms of how you approach this? Talk to me, talk to me. Remember, today's focus is not completely about whether you could do the answer by yourself. It's about making sure you understand the thinking. Because when you leave from this session, it's about now going on your own and looking at your notes, looking at questions and making sure you understand, okay, this is what I'm supposed to be thinking. This is what I'm supposed to be looking at. Because that's what students' mistake is. They don't prepare themselves to manage questions based on what they learn. All right, so let's take it down to the next one. Before we continue, I know this is a bit overwhelming because algebra is rough, but everybody feeling okay though? Are you learning? That's my most important part. Are you guys learning? I'm not doing the next question until I see everybody responding to that question specifically. The are you learning question, because that's important for me. Because guess what? To be honest, by the time we go through 3 papers, you're going to start to see the patterns because, you know, CXC have patterns. So once you get familiar, you're going to start to realize, okay, I remember when I see this, this is what I need to do. This is what I should be thinking. And that's what we need to be developing, our line of thinking. All right. So great job, everybody. Here you like hype me up, eh? All right. So let's look at this here now. We see here another question that gives us an equation that equal to what? What is it equal to? It is equal to 0, and they ask us to solve. You see that? So you see here, we're starting to get a trend. No, this is not like the other questions. We can't solve using factorization because it's not a quadratic equation. You're not hearing me? Anybody else not hearing me? Let me know so I could let him know if it's his own or if it's me need to fix. So if you can hear me, just confirm so that I could. Somebody type in the chat and tell him leave and come back because it's probably his audio. If he can't hear me. All right. Thank you so much. Okay. Now let me explain something to you guys. Okay, good. If you see this question here, solve. What you think you need to do based on what I've been telling you all afternoon? Should you be using this equation just like this to solve, or would you use the answer that you got before? Because this is the next thing students is make a mistake all the time. Anytime you see a question that connected like this, and look at it. Look at A, not A, but look at B and B1 and B2. Anytime you realize that the questions using the same equations, they don't expect you to use this here. They expect you to use the answer that you found before. Everybody with me? Because the truth is, you can't solve this if you have 2 separate quantities. And why do I say that? You might think, oh, let me move this over. But why you gonna move it over when you're solving, you need all the x's on one side, which is your left-hand side? Everybody see what I mean now? So you need to find this, you need to use the simplified version of this equation. So I'm gonna put here, use simplified version. And the answer that you got before is what you need. So let's write that back over. So you would put since, how much marks this is. And to be honest, based on how much marks it is, you don't need to, but it's good practice to communicate what you're doing to get full marks, okay? And just for the purpose of reference, let me see what the working did for this one. Oh, look at there. Bravo. Look at right here. So you see, I was going to use the word since this is equal to that, then. But you see, it's the same thing here. So this is what I want y'all to understand, the language that you need to use. Because they ask you to solve this. So you just can't go and write this and start solving. You need to make sure you communicate why you're using this version of it. Everybody understand what I'm trying to say? This is where now you're looking at maximizing your marks and making sure you heighten your chance of getting a grade 2, a grade 1 versus a grade 3. So what is the point? You have to say that since this is equal to the answer you got before, and in this case, they said, as shown in part 1, and you see what words they use, so. You see what symbols they're using, therefore. Please get accustomed to using this type of language in your working. So let's work it out over here based on how we were working it out. Where was that? I got across too much. Where was I? Okay, yes. So how I would have written it out is since this equation, since this 1 minus x minus 4x is equal to the answer we had before, which is x 4x minus 3 bracket over 1 minus x. I would say since this, then, because if this is equal to 0, that means this is also equal to 0. And that's the statement you have to say. If you don't say that, you're not going to get 1 mark. Even if you work it out correctly, you're not going to get a mark for critical thinking. And just a side note, when CXC distributing marks and the grades, there's profiles. There's profiles A, B, and C. 1 is for logical thinking. To get a 1, you need to at least score a B plus or A in all 3 profiles to get a 1. Everybody understand that? If you don't do this, you can't get a 1. If you don't use this type of language and sequence in your answer, you will never get a 1. They will just give you a high 2. So you might see a B, B or something like that, which is a 2. Okay, so this is me just making sure you understand the importance of saying since this, then that. So let's continue. So since this is equal to that, then x 4x minus 3 over 1 minus x is equal to 0. Now we can take it from here. So let's go. What do we do next? If we just want x by itself, what should we do, guys? What do we always try to get rid of first? What blocking us from going forward? This has a denominator. So we need to get rid of the denominator. How do we get rid of any denominator? We multiply, because remember, this means divide by 1 minus x. So to get rid of it, we need to multiply by 1 minus x. Whatever you do to one side, you have to do to the other side. And guess what's going to happen? Luckily for us, this and this is going to cancel. So we're going to just be left back with x 4x minus 3. What am I going to have on the right-hand side? Anybody could tell me? Anything times 0 is what? Excellent. Excellent. So what do you do from here? Yeah, remember the rule I showed y'all about the 0 rule? If 2 things multiplied together give you 0, what does that mean? Either the first thing is equal to 0 or the second thing is equal to 0. So this is something I want y'all to always remember. It's always the same. Once you reach to a linear equation and you got 2 things, it's either x, so you put therefore, x is equal to 0 or 4x minus 3 is equal to 0. Everybody see this part? Talk to me, talk to me. So luckily for us, we don't have to worry about the first part because we already have one value. X is either equal to 0, so now we just need to figure out what is the other one. So let's go. What do I move over first if I want to find x? Should I divide by 4 or move over the 3? What should come first? Excellent, you move over the 3 because it's like a tail. Move the tail first. So when the tail moves over, what do we get? we're going to end up with 4x is equal to positive 3. When it moves over, it changes signs. What do I do next? Because I don't want 4x, I just want x. I have to do the opposite. What is the opposite of multiplying by 4? It's to divide by 4. So this will cancel. So our final answer is equal to 3/4. So you see how even though I don't work it out, I always come down to the end. So x is equal to 0 or x is equal to 3/4. And that's it. Let me just erase this example from the bottom here that we used. Again, what you're going to start to realize, you're going to see these questions coming back over and over in different forms. Check-in time. How you feeling? Are you okay? Are you over it? Talk to me, talk to me, talk to me. Before I continue the last one, oh, I have to teach y'all this because most times students don't know this last one. Natalia, you over it? Oh boy. Are you learning at least? Because you know, even if you're over it, you know, we gotta tug it, we gotta tug through it. We gotta tug through it. All right, so let me go. We're getting there, we're getting there. Don't worry. This is our first run through of paper question 2. Question 2 is honestly the most challenging one of, to be honest. So you should be okay after you start studying based on what we've done today. Now, I'm going to be honest with you. This topic here is variation, proportionalities. Anytime you see varies directly, so I'm just going to quickly, because I haven't done it with either classes. And it's only when I was going through the past papers, I realized how often they bring it back. So I'm going to use this question as a quick learning opportunity. It's pretty easy. Proportion and variability comes in 2 versions. You could either be directly, so it's direct variation. It's actually very easy, or indirect or inverse variation. Actually need everybody to write this information down, please. Write this down in your notebooks. It's very, very easy. It's just 2 things you have to memorize, okay? When they tell you something is directly varied or indirectly varied, the first thing that needs to come to your mind is that there's a connection between 2 things. But before I start, let me know if you are ready. So this is something new. Well, kind of, but it's easy. Let me know if you're ready. Come on, let's go. All right, so let's go. Now, in maths, you know, we always do X and Y. So this is something we learn in functions, we learn in all kind of thing. So the truth is, okay, no problem, Lovey. Get comfortable. Even if, for example, moving forward, you just want to watch, that's okay with me. At least you just pick up what you could pick up, okay? All right. So, you know, like in maths, we always say X is connected to Y, right? Y is equal to X. There's something or some formula that connects X and Y. Everybody remember that? That's the basics. That's the basics. Talk to me, talk to me, talk to me. Yeah, remember that? X and Y always have a relationship. Okay. Now, it's the same concept, but just under different conditions. So essentially, this is how that is represented. Y is directly varied to X. Or they might say Y is varied indirectly to X. And we should know this. If this is X, we know that this is the inverse of X, right or wrong? That's the 2 concepts that you need to know. So a quick example of what this means. Let's say the more hours you work, the more money you make. So it means that if the hours that you work increase, that means what? The money that you get increase. Everybody see that? So here we realize the money would be the Y and the time you work would be the X. So the more time you put in, the more money you put in. So if the time increase, the money increase. Everybody with me? That's an example of what I mean by a proportion and variation. What is the opposite? Let's say the more you eat, what's a good one, eh? What's a good one? The more you drive, the less gas you have. That's perfect. So the more that you drive, you realize the less gas you get. That is why this would be an indirect variation. Because as one of the variables increase, the other one does what? The complete opposite, it decreases. Everybody understand those two examples? I think those are the two perfect examples to use, especially when it comes to proportional. So you see, as one increase, the other one increase, that's a direct variation. The other one is the inverse. So as one increase, the other one decrease. Okay, so that's the two perfect examples you need to think about. So anytime they explain to you something is proportional or direct or indirect, this is the first two things you need to write. Now, what does this symbol mean? This symbol means that Y is affected by some constant. Sometimes the constant could be double, sometimes the constant could be a fraction, it doesn't matter. But the point you need to remember is that this can be translated to Y is equal to KX. So there's some constant, K is the constant that affects the connection between the two. So as I was saying before, the connection could be doubling, so K would be 2. The connection could be tripling, so you multiply by 3, or it could be a decimal. That's it. That is literally it. And so for the indirect variation, obviously, instead of Y equals to X, Y would equal to K times 1 over X. Everybody see that? And this could also be represented as well. If I multiply these two, what's going to happen? It's going to be the same thing as K over X. Talk to me, talk to me, talk to me. And we're going to look at some examples of how they use. Because to be honest, that's it. There's nothing more, there's nothing less. The most important part to remember is these two. When it is direct, Y is equal to KX. When it's indirect, Y is equal to K times 1 over X. That's it. So we're going to look at an example, and then I'll show you how to use the information. And based on what I saw for the past 3 years, a question like this came. So 2021, it actually came as well in the January paper gone there 2 weeks ago. And it came in 2019, 2020 or 2019. So this is why it's important for us to go through this now, just for the purpose of being aware. So let me know when you are finished copying this down. All right, so take a deep breath, take a deep breath, take a deep breath. And know that just being here, you are putting yourself in a stronger position to move forward, okay? Exposing yourself now to these types of questions are gonna make you stronger and help you even study better. Because guess what? When you're studying, you're gonna start to remember, oh, I need to remember this part. I need to focus on this part. And that's the best way to study, okay? All right. And I just want to say I'm super proud of you guys, because ain't nobody want to be doing work on a Sunday night, but we got to do what we got to do, because we have 103 days until our exams. All right. So let's jump straight into the question. You see, first thing first, when I see questions like this, I'll be like, oh my God, all these words. So let's take a deep breath and be like, all right, time to underline. So the first time you read it is not to even try to answer. It's about understanding what all this information is. So let's take it step by step. So let's go. The distance needed to stop a car, D. So you realize, what does D represent first thing first? Let's see if we understand what information we get in here. What does D represent so far? So I'm going to read it again. The distance needed to stop a car, D. Because guess what some students would think? Some students would think D represents the car. You know, we can't take nothing for granted. D represents distance. So to be honest, you have your pencil, you start labeling your things then. So distance is D. So let's go now. D varies directly. So we know we have a direct variation. So in this case, we know we should be thinking about this equation. All right. Even though they're using different letters, you still need to remember that you're using this equation, right, as the square of speed S. So they've now given us two variables. They gave us D and they gave us S. So we're going to write speed is used to represent by S, and we know we're using direct variation. And when we talk about direct variation, because of how my mind works, I need to write down these things even before I look at the question so that I don't get overwhelmed and forget. So the first thing you should do is write down the direct variation equation, which is Y is equal to. And in this case, if you was to use the letters, how would you write it? Based on the sentence itself, what letter would come first? Let's see if we're figuring it out. Excellent. Everybody see why it would be D? Because just the sentence says so. D, the distance varies directly. So you just write D. So D varies directly to what? The square of S. That's it. Everybody see how I got that? If no, you could tell me no, okay? All right, so let's continue. At which it is traveling. A car traveling at a speed of 70 kilometers requires a distance of 40 meters to make a stop. What distance is required to stop a car traveling, blah, blah, blah. Now, guess what? You don't stress yourself about all these things. Before you even touch these things, what would be your next step? Your next step would be writing out your equation. So what would you write based on what you remember? D is equal to K S squared. Everybody with me? Because now that you have your base, you can then start to substitute your values and figure out, okay, what do I have? What do I need? Students' mistake is they just jump straight into the question and start seeing numbers, but they don't understand the numbers that they have. So whenever you see a topic and you know it has a formula, write the formula down immediately. Then that is what is going to give you a sense of direction. What do I mean? That's when you're going to start to figure out, okay, let me see what they give me and let me see what I could do with it. That's what you need to do first. So let's do that. So after we have our information, we got the information from the first sentence. Let's pull up what we need from the second sentence. A car is traveling at a speed of 70. So what do we have? We have S. S is how much? S is 70. Everybody with me so far? Then what did they give us? They gave us this speed is equivalent or matches up with 40 meters. So D is equal to 40. Everybody following me so far? If you were working this question, even before you continue, what would be the smartest thing to do here? And to take this and substitute it in your formula. Because what you would realize is you would realize what is your unknown. And then we're going to go from there. And just to jump ahead, I would just jump ahead without doing it just to show you why it is important. So I can just skip that and continue as if like being on a strategy. So I just writing down things. So let's read. What is the distance required to stop a car for 80 meters? So they give me a new speed of 80 and they're asking me for D, which is a question mark. Some students will get stick here. You know why they will get stick here? Because they'll be like, well, I know I got this and this, but may know how to get this. But if you were to use this information with the formula, you're going to start to realize what you need to do. So let's do that. Let's write the formula. D is equal to K S square. Which values do I have? I have D. So let's substitute it. 40. What else do I have? Do we have K? No. So let's put back K. But what do we have? We have S. So what I put here? 70 square. Based on this equation, guys, what would be the smartest thing to do? Let's see if we're thinking. Anytime you have an equation with an unknown value or letter, what is the smartest thing to do? Take a guess. If you don't know, say you don't know. When you say pull out, what is another way of saying pull out? I think I know what you mean. When you say pull out, finding what K equal to it wouldn't be the smartest thing to do, guys. Solving for K. Right or wrong? Find K by itself. I know exactly that's what you meant. So pick up yourself. Everybody else, you see what I mean? Even before we look at what the question asking us for, logically, they gave us some puzzles and we know the equation and we realize, oh man, we got one unknown. Because guess what? This is exactly what we need to even work out the other part. Everybody see what I'm saying? The thinking part, the understanding part. That's what I want to know if y'all understanding. So what do I do to get K? Calculator, people. What is 70 square? So you go back, 40 is equal to K. What is 70 square? Nobody calculator, nobody on calculator's duties tonight. Thank you, Damian. 4900. So question for everybody, how do we find K? What do? We multiply, we divide. Do we divide by 40? Look at what we're trying to get. We want K by itself. So what should we divide by to get everything gone from by K? We need to divide by 4900. Whatever you do on one side, you do on the opposite side. So you're on the right track. So K is equal to whatever this is equal to. And what is that equal to, guys? 40 divided by 4900. You're going to end up with 0.00816. But guess what? This is not what they ask us for. So now let's see if we could figure out what they ask us for now. So as we noted before, they gave us what? They asked us for the distance if the car is traveling at 80. So write the formula again. D is equal to K S square. What was the S that they gave us in this case? S is equal to 80. You realize what we're talking about now, guys? What we need to do now, don't we have everything we need now to find D? Before I continue, talk to me. We're almost done. I know some of us holding on by a little bit, but you know, I don't want y'all to give up yet, because the more questions we cover, the better it is for us later on. So Damien said yes, Myrtle said yes. What about everybody else? Following. So since we know this is it, this is K, and they gave us S, the new S, we could find the new D by using the formula. So D is equal to K times S square. We just found K. K is 0.00816 times, what is S square? 80 square. So once we calculate that, we find the answer. And that's it. So answer would be 80 square times, anybody get answer yet? I want to see if y'all could get the answer using your calculators. Tell me what y'all get. Because a lot of people would get we would get like a million different answers based on your calculators. So at least let me see if y'all could work out this question and get the right answer. So Damien got that. Damien, check something missing with your decimal place. Anybody else get anything? So I got 52.224. And how you know you're kind of right? Look at how close the numbers is. Doesn't this seem right to you based on what you had before? Before you had 70, 40. Now you got 80, 52. Isn't that in line? So you see, as the speed went up, the distance went up. Everybody see what I'm saying? That's how you know if it's correct. If you had gotten less than 40, you know your answer wrong. You went up a little bit in speed, you went up a little bit in distance. So confirm if you see what we did here. This on the side here was just our explanation of us taking out the information from the question, but this is where you would get 1 mark here to find K. But they would break it up, obviously. You would get a half mark up here, a half mark here, a half mark here, a half mark here. So that's a perfect example of variation. Since you guys are doing this for the first time, remembering what did you have to find first? We had to find K first, and then we just substitute. Out of 10, how you feel about understanding the concept of variation for the first time doing it? 7, 4. Okay. Don't be afraid to be honest, guys. If it's 3, 2, tell me. All right, so let's just do a check off on everything that we've done so far. We reached January 2021. Seven, okay. All right, so this is where we reached today. So we didn't get to do January 2022. We did January 2021. We're there. Can't be that we just did that. What else we do? What's going on here? I feel like we did a lot of papers. How much papers did we do? So let me see. What exam was this first one? This was January 2021. Guys, we only did 1 paper. If anybody here, this can't be right, and there's something wrong. It's only 1 paper we did so far? No. We did 1 before, we did 2. That's weird. I wonder if it was May and it just disappeared. Let me check. Yeah, I probably need to zoom out. Yep. It's panicking there for a minute. So we did June and January 2021. And like I said, this paper was rough. You know why it was rough? Because this was the year that they brought back paper 2, because in 2020, there was no paper 2 in June. There was only a paper 2 in January. So this year, a lot of people, this was, I think, the worst failing rate for a lot of people in maths last year. So this was rough. The June paper was rough. No lie. So we did January, June for 2021. The year before was way easier. So let's just tick off. Let's just tick off these two. So May 21, so we did these two. Now I'm willing to do one more and I'm just gonna go through the answers. You don't have to contribute, but just to show you certain things, but it's if you guys want me to. So I'll just run through one more and without any questions, but just to go through it, just so you could see. So let me know if you're up for it or you want to end here. Yeah. Easier based on this. Let me know what y'all want to do. Okay. All I need is one person. If one person willing to do it, I'll do it with you. If anybody ready to leave, you can, but I would just advise still to just hold on and follow. All right, so I'm just gonna bust through these questions quickly, just so you can get an idea. So here we have factorization, and it's more than one factorization, okay? If I look at this, the first thing you should realize is that this is an easy, this year is 2020, January 2020. Y'all realize two January papers are way easier than June papers. So to be honest, if I were you, I would start using January papers to get myself familiar. Practice those questions first before you go to June. Okay, let January be like revision and then June will be your test. Okay. All right, so let's go. We have here two terms. So it's not the difference of two squares. So this must be distribution. Right? So that means something is common for both. Looking at the two coefficients, it's not the coefficients because 5 and 12 have nothing in common. But both sides do have an h. So I could pull out the h. So when I pull out the h on one side, I end up with 5h minus, put back the 12. Since we took out the h, it's gone. And so just the g is left back. That's it. You get your one back. All right, moving along. As we see here, we're looking at a quadratic equation. So what should start coming to your mind? The only options you should be thinking about is the perfect square or AC rule. And you know it's not the perfect square because 6 is not a square number. Keeping in mind, even when this is a square number, you still got to back check the middle terms. But this one is easy. This is a clear AC rule. So we multiply A, which is 2 here, and C, which is -6. So that is 2 times -6 gives us what? 12, -12. So let's find the factors of -12 that are going to give us what? -1. Everybody should realize why it's -1, because -x by itself is the same thing as -1x. So let's break it down. I'm not even going to do 2, 1, and 12 because we know that could never give us no close to 1. So let's try 2 and 6. We know this is going to give me +4. This is going to give me -4. What are the other two factors? 3 and 4. So if I have -3 and 4, that's going to give me +1. But if I have 3 and -4, that is going to give me -1. So I know these are my two factors that I need. So we know after you find your factors, you are rewriting your equation. So we're going to end up with 2x squared, right? Now here's the trick about this. Why should I write the 3 first when I could write the 4 first when 2 and 4 got something in common and the 3 and the 6 got something in common? So I'm just going to write -4x first, then plus 3x minus 6. Everybody following me? But just say, let's say you just went and did it just the way it did. So I'm going to do it that way as well, so you don't get overwhelmed. So let's just write the plus 3x and the minus 4x minus 6. You're going to get the same thing. So before I continue, just checking in. How everybody feeling so far? Everybody good? Because as you see here, we starting to repeat the same process, same steps, just with different questions, right? Okay. Big up on yourself again. So let's look at what we have here. So we know since we now have our 4 terms, what are we using now? Grouping. So we group up with things. Let's go. What's common between 2x squared and 3x? Nothing else but x. Because 2 and 3 have nothing in common. So the only thing we could pull out is our x's. So we're going to pull out our x. Once we do so, what we have left back is 2x plus 3. Everybody with me? Same thing we're going to do on the other side. So what is common between negative 4x and negative 6? First thing first, what we should realize is that the negative sign got to go first. We always start with the signs, then the coefficients, then the variables, just so that you don't forget anything. Okay, so we did the signs. Both of them have a negative sign, so we pull it out. Now let's look at the 4 and the 6. What do they have in common? Thank you, Myrtle. They have 2 in common, so we pull out the 2. So since we pull out the negative, it's going to be a positive. We pulled out 2, so what's going to be left back? 2, and we didn't trouble the x, so we write it back. Agreed? We pulled out this negative, so since we pulled it out, what's going to be left back? A positive. And 6 divided by 2 is 3. Let's look at what we have. What is an indication, again, that we're going correct? My bracket here is matching with this bracket here. Everybody following? You see the same thing keep happening? So since our brackets are matching, we pull it out. So we end up with 2x plus 3. And we write the others in a bracket by themselves. So we end up with x minus 2. They didn't ask us to solve. They only ask us to factorize. So are we finished? Because some people might forget and go do the whole equals 0 thing, but you realize they only ask us to factorize. And so this is your answer. All I need from you guys is a good to go, and we keep it moving. So we halfway there. So those are our 2 factorization questions. Same steps. So 2 persons said good to go. The faster you are, let me know, the faster we finish. All right. So let's bust these 2. Hello, could you hear me now? Hi, could you guys hear me now? Okay, so sorry about that. I was just giving some really important points. So let me just repeat quickly what I was saying. So whenever we see the word solve, the first thing that comes to your mind should be whatever variable that's in the equation at the end of your answer, you must have that variable is equal to a number and nothing else. Okay, so that means that you need all the r's on one side and all the numbers on the opposite side. Okay, so here we see here, it's already a linear equation, so you don't have to worry about getting rid of the denominators and none of that stuff, right? But what you do notice is that we have brackets. And as I was saying before, we always get rid of the brackets first. You can't do nothing until you get rid of the brackets. So we know getting rid of the brackets mean multiplying out the brackets. So that's 3 times r minus 3 times 5. So let's write out what we have so far. We don't touch this side yet. We put it back. We focus on the brackets. So 3 times r is 3r, right? Minus 3 times 5 is 15. All right, everybody here with me so far? We're almost there. So this is just the basic stuff. Get rid of your brackets. Next, we need, what do we need? We need all r's on one side and all numbers on the other side. Now, let me just pause this music. As an advanced math student, one of the things you should realize is if you carry this r over, it's going to give you a negative number. So I'm going to do it both ways. I'm going to do it the way, and then I'm going to do it a more logical way. So I'm just going to do it the way most people would do it, which is just carry over the r and carry over the 3. So let's do that. So we have r, and if we bring over this r, it's going to become negative, right? And then if I have, what am I having over here left back? I'm going to end up with minus 15. And then when I carry over the plus 3, is going to give me minus 3. So basically, what we're going to have left back is negative 2r is equal to negative 18. Everybody following me? Again, we want to just get r. So what do we divide by? Obviously, we divide by the negative 2 to get rid of it. Whatever you do on one side, you do on the opposite side. So you cancel, and you're going to end up with r is equal to positive 9, because you know the negative and the negative cancel each other, and 18 divided by 2 is 9. So I'm just going to leave it here. But most times, what I would have just done, instead of carrying over that, I would have leave r's over here since it's the bigger positive. Yeah, want me to show you? Let me just show you quickly. This is just to expose you to the different approaches, right? So you start off with this. 3r minus 15. Some people calling me, but I can't answer. Sorry. Apologies. So yeah, as I was saying, let me just fix this properly. Minus 15. What I would have done, instead of carrying over the bigger r, I would have bring over the smaller r and carry over the 15. So what you would have realized that would have happened, you would have ended up with positive terms versus negative terms. Everybody see what's going on? So you would end up with the plus 3 and plus 15. You would end up with a positive 3 minus r. So you would end up with positive 18 is equal to 2r. Everybody see the point I was making? It's all about looking at both options. And you do the same thing, you divide by 2. You divide by 2. So you end up with r is equal to 9. Same thing. It's just about logic and which one is easier for you. If you're comfortable with negative signs, use the left-hand side, nothing wrong with that. If you are more confident with positive signs, you look at the question and you work it out in such a way that you end up with the positive values. Everybody good to go? And what we should start seeing here is that the concepts are becoming a lot less overwhelming because they are repeating. The whole idea of solving, the whole idea of transposing. Again, I hope you are picking up on the patterns and are able to work from there. I love making the subject of the formula. We did this, so they should be easy. I'm just going to rewrite it to make it look a little clearer. And then we're going to knock this out quickly. Don't care, guys, what symbols they bring. You focus on the things that they ask you to make the subject. So there we go. What they ask us to make the subject, the K. For me, I like to put the K in the box, so you know everything has got to go. Agreed or disagree? Because sometimes you're working it out and you forget, oh, man, is the K I really want. So put a little box around your K. Remind yourself that that's your focus point. That means everything has got to go. So what would you get rid of first? You obviously got to get rid of everything, but what do you get rid of first? You get rid of the tail. So when we get rid of the tail, let me draw this smaller. What do we end up with? We end up with 2a minus 3t is equal to pi k square. Again, when you do it like this, you put your box, you have to ask yourself, which one is the easier one to get rid of first? You can't square root yet because you have this pi. So what we do next is divide by pi. Let's get rid of it. Whatever you do on one side, you do on the opposite side. Keeping in mind, you realize it's the whole entire thing I had to divide by. So what's gonna happen? This gonna cancel. So I'm just gonna rewrite it to make it a lot easier. I'm just gonna switch the two sides and put the k in front. So we end up with k squared is equal to 2a minus 3t over pi. So what is my last step? What is the opposite of squaring? Square root, because they cancel each other. Whatever you do to one side, you do to the other side. And keeping in mind, I am square rooting the entire thing. I am not just square rooting the top. So our final step is k is equal to the big square root of 2a minus 3t over pi. How are we feeling? Got it? So all this was transposing. That's all we did here, transposing. All right, let me just move this over, and last question, and we're done for the night. Again, if you realize a lot of this is difficult for you, you know that it means that algebra is a weak area for you, okay? And I sent you guys the website so you could actually study from this. You could study from past papers, you know. So they got a question and they got the answers. So it's just for you to sit down and see if you understand and you work it out from there. Okay, that is my personal recommendation to you. All right, last question for the road. A farmer plants 2 crops, potatoes and corn, on a 10,000 hectare piece of land. The number of hectares of corn planted represented by the letter C. So I'm just going to underline that. So C for corn must be at least twice the number of hectares of potatoes, which is P. So P is potatoes. Write 2 inequalities to represent the scenario above. I remember this question. They were talking about this question. If 10% of the population that sits here answer this question, a lot of people answer it. Hardly anybody answers this question. So all I'm going to ask you is, do you know what to do with this question? Because all they're asking you for is to write 2 inequalities. So that means you need to take these sentences and write them as algebra expressions. Do you know what to do? All I need is a yes or no, and then I'm going to work it out. Kind of. No. I'm watching. Talk to me, because this would also let me know what areas I need to do some more revision in. So the more information, the more useful I will have. No? Okay. All right, so let's break it down. They said 2 expressions, right? If y'all could hear me still, type yes. Let me see something. Y'all can hear me? Okay, because my Wi-Fi just dropped a little bit. All right, so last question, guys, we're almost done. So let me just zoom in a little bit so we could identify the 2 sentences. So as you realize, they want 2 inequalities to represent the scenarios above, and it's easy. The first sentence is one, the second sentence is the other. Everybody with me? That's the first thing. CXC not going to try to confuse you. So you got two sentences, you got two expressions. So all we need to do is figure out what is the expression for the first sentence, what is the expression for the second sentence. So let's take it step by step. First one. Again, when I read this one, I was like, yikes. So this is just about you learning now how to do it, okay? A farmer plants two crops, potatoes and corn on a 10 hectare piece of land. What does that mean? That means both of these two things must fit on the land. So let me ask you if y'all understand that's what they're saying. So you see, this is where the English part is coming with the maths. Everybody with me? So the first sentence is saying is only two things are on this piece of land that is 10. So how would I write that? The corn plus the potatoes must fit on the 10 piece of acres land. But guess what? It didn't say it exactly fitting. Y'all realize that? It didn't say that the two crops are exactly the 10,000. It just said that these two things are on the land. So what does that mean? That instead of equal, what other signs do we have? Yeah, I realize we do have less than and equal to and greater than and equal to. So which one would you pick? Because we know it can be equal. They did not say exactly. Exactly would suggest that it's completely equal. Everybody following me? Talk to me if you're following me before we even continue. So this is how we change our sentence then. So which one would you pick? Would you pick one or would you pick two? And think about it. Think about it. It says that the corn and the potato is on the land. So would the corn and potato be greater than the land, or would it be less than or equal to the land? So would you pick one or two? This is just you thinking now. Would you pick one or would you pick two? Everybody try right now. Some people saying one, some people saying two. What about everybody else who is here with me? Come on, let's go. All I'm asking is to try. If you were to pick one or two, and what does one suggest? When you add the corn and the potato, should it be less than or equal to the 10 acres, or should it be greater or less than the 10 acres? So would you put one or would you put two? The answer is one, because how you gonna get more product than land? Everybody see that? So we see why it is not equal to, and we see why it can be greater than, because it says it fits on a 10 acre or 10 hectare piece of land. Everybody following me? And guess what? That's it. That's the first expression. So everybody see how we got the first expression? It's just about translating the concept into an equation. So let me know if you understand how you should be thinking. Something and something is obviously addition. What are the two things we add in? The only two things they tell us, the two crops, the potato and the corn. What is the potato and the corn doing? It's fitting on this piece of mountain land. It can be equal because they didn't say, if it was exactly, okay, equal. They didn't say exactly. So it's either less than or equal to or greater than or equal to. And it can be greater. So let's look at the second equation now, or the second expression. The number of hectares of corn planted must be twice the number of hectares of potatoes. So what words we seeing? We seeing the word at least. And what else we seeing? We seeing twice. So let's go. Let's break it down again. So that means that the number of hectares of corn planted. So what letter should I write first? What come first? What should I put down first? I should put down C first because they're talking about the corn first. Everybody with me? And then they say C must be at least twice the number of the potato. So we know something gonna happen with 2 times potato. So guess what we need to figure out again? Which sign we're going to put? Is it the less than or equal to sign or the greater and equal to sign? That's the tricky part. Excellent job. Very good. Because that's the smallest value. So that means that it must be this and bigger. Everybody see that? And guess what? That's it. 1 mark for this, 1 mark for that. That's it. So you see, I just want to point out something now that we ending. You realize a lot of these questions, I'm going to show you something. Sometimes they're going to give you direct questions. And when we say direct questions, what do we mean? We mean you just got to solve it and you put the answer. Y'all realize that? But what you should also start to realize is that they're giving questions that are thinking questions. And the question from last year, this is the most worded problems they've ever brought in a paper too. I was watching some videos with some lecturers discussing as a collective about what they felt about the paper. And they said straight up, most of their students can't answer it because they weren't prepared to think. They were prepared to see an equation, to simultaneous equation, and they solve it. They were prepared to get the expression and solve it. They were not prepared to get a real life situation and then working it out. You realize they didn't even ask us to solve P? Anybody realize that? Because usually they would have asked us to figure out what C is and what P is. You realize they didn't even care about that because most students can't even do this. So my advice moving forward, when you are studying, do not just focus on just answering the questions. Make sure you understand why, make sure you understand how. Agree or disagree. And so this is the purpose of us doing what we're doing today. The purpose of us doing what we're doing today is to show you how you need to prepare. Hold on there. Hello, y'all hear me? So before I end class, I just want to give y'all some tips. Tip number 1, exposure. What does exposure mean? The more questions you start to look at and even if you don't work it out yet, the more questions you familiarize yourself with from now, the easier understanding the content will be. So that was my whole strategy. Start now. Because when I told some teachers I done going through past papers, it was like, what? Already? I was like, yes, because I don't see what's going on with CXC. CXC is moving away from the memorizing questions where you memorize how to solve this, how to solve that, how to solve that, and then moving towards critical thinking questions. Preparing you guys to do so, but you have your own responsibility for yourself. Don't just wait on me. Make sure you use your time and use the website that I sent you to evaluate the types of patterns that come with questions. Okay, so we just did this one, and so at some point in time I would like us to do more, but I would like some feedback based on our session today because we did a lot and it was heavy. It was way more heavier than question number 1, obviously, because we did way more in the same time. So how y'all feel about today? Did you feel like it was productive, useful? Did you realize anything about what you know and don't know? So just give me some feedback before we leave, because it also helps me like prepare for you guys in the future. Very useful. Okay. All right. You missed a lot, but you also learn a lot. Okay, good. Very useful. It was overwhelming, but I realized I have a lot of work to do. Very good point. That's the point of it as well, for you to see, okay, benchmark, where are you in terms of what you remember and what you can do so that you can start organizing moving forward. All right, so next class, I'm gonna be honest, algebra is a heavy thing. I'm gonna do another one on algebra, to be honest. But next class, next Sunday's functions, relations, and graph. It's not as heavy because it's a pattern. They bring back the same things over and over and over. So yeah, hopefully you guys are here so that we could go through it. Okay. All right. So that's it for today's session. I'm going to upload this video to YouTube. So if you guys need it for my private class, you know where to find it. For my students, just message me and I'll send it to you. Okay. That's it for today's class. Have a good evening. Bye.